In this video, we are going to be talking about correlation coefficient. Remember that correlation is basically a synonym for association, and that those are not the same thing as causation. So those are basically the same, but it's not necessarily the same as causation. So we're talking about association here, and the name of the variable that we're going to be learning is a correlation coefficient, but it's essentially just still talking about association. Okay, so we're going to leave this ready. We're going to come back and write on it in a minute. For right now, we are going to look at this little graph here. So if you look up the top, you'll see right now we have a correlation of 0.723. And if you look at this scatter plot, it looks like a scatter plot. Okay, I've got a little dragger here, and I want you to watch what happens. So I'm going to move this to the right, and you can see the points are getting closer and closer to the line, and this correlation up there is getting a little bit bigger. And when I take it all the way to the right, the points are perfectly on the line, and the correlation is 1. If I take it back to 0, there's 0, and you can see what the points look like here. Now, if I were to take an individual point and drag it, and if I were to do this with a bunch of points, you can see that this number is starting to change as I pull these points in closer to the line. So as these points are getting closer and closer to the line, the correlation is getting bigger. Okay, see how I made it all the way up to 7 by just dragging those points in? If I take these down into negatives, the same relationship happens, except now the slope is negative. Here's another model of the same thing. So you can see up here it says R equals negative 0.9905. So the correlation coefficient is also known as the R value. So often you'll see it as R equals, and that means correlation coefficient. I'm not sure why it's R versus like C for correlation coefficient. I'm sorry, it just is. But if we take that and we can see now it's negative 0.9, so it's a negative association. If I drag it now, I'm at negative 0.27. You can see it's a much less strong association, right? These points are just kind of scattered everywhere. If I bring it up to 0. Oh, sorry, those last numbers weren't right. I was looking at the wrong thing. So if R is 0.807, now I've got a positive slope, and it's pretty clear that there's a trend here, right? It's not as strong as when they're like exactly on the line, but it's pretty close. All right, here's what a 0.9 would look like. Just to kind of, you're supposed to just kind of get a feel for what these different numbers look like. And notice that I can never go higher than 1, right? Like 1 is my boundary on the top and the bottom. Okay, so let's go back to our notes and let's take a look at some of the things that we can say about this. So first of all, we learned that correlation coefficient can also be called the R value, and it measures both the direction of the slope, not the number of the slope, but the direction of the slope, and also the strength of an association. So in general, R is bounded between 1 and negative 1. So R must be less than or equal to 1 and greater than or equal to negative 1. And if we picture it on a number line, we have -1 over here and 1 over here. We can kind of label what the different parts would be. So halfway in between, that would be 0. That would mean no association. 0. When you are between like 0.8 and 1, that is considered to be a very strong and positive association. Everything over here would be considered a positive association, meaning the slope of the trend line is positive. Everything over here would be a negative association. I realize I did not actually set my scale up to be like a real scale here. Sorry. Right? Like this half is way smaller than that half, but that's okay. Okay, so between 0.8 and 1 would be a very strong association. Same thing on the other side. -0.8 to -1 would also be a very strong association. I'm not sure that we need to write it on both sides, but I will. Okay, and then from 0.6 to 0.8, from 0.6 to 0.8, from 0.6 to 0.8 would be considered a strong association. From, let's call this 0.4 to 0.6 would be considered a moderate association. And from 0.2 to 0.4 would be considered a weak association. And below 0.2 is basically no association, or a very, very, very weak association. None or very weak. Now you have to consider context when making these choices. These are kind of arbitrary numbers that I picked. I found them. Someone else thinks that those are also the right numbers. But it does kind of depend on context what you would consider to be strong versus weak. So the same thing would happen, like this should be mirrored on the other side, right? Like all these things are also true in negatives. It's just that the slope would be going down instead of going up. Another thing you might be asked to do is to interpret the association between two variables. So for example, let's say the association between social media use and well-being is measured at R equals -0.29. Someone went out, they collected some data on how much time people spend on social media and made them take a survey about their well-being and general feelings of happiness. And they made a scatter plot. And when they ran the numbers, they found that the correlation coefficient was -0.29. What exactly does that mean? So we can tell from looking up here that -0.29, that puts us right in that weak to very weak negative correlation. So that would mean that as one variable goes up, the other variable goes down. So we could say that as social media use goes up, well-being goes down. But it's not a super strong association, right? It's pretty weak. The data is pretty scattered. There is a trend, but it's not a strong association. So we could say that there is a weak negative association as social media use increases, well-being decreases. All right, for your practice problem, I have drawn you a graph here showing income on the x-axis and health on the y-axis. I want you to estimate the R value and interpret it in context. So do you think this R value is close to 1? Do you think it's close to 0? Pick a number. What do you think it is? And interpret it in context, please. Good luck.